Very good evening, students. Myself Rajeev Singh, and in this lesson I am going to talk about Sine Bar in very much detail. Students, this Sine Bar comes like there in the chapter Metrology, and it is very much important from GATE and ESE point of view. So this thing that you are looking at is what we call as Sine Bar. How do we use this Sine Bar? To measure the angles, and what are the limitations there with the Sine Bar, as well as we will also be learning what will be the error in measurement when we measure the angles with the help of Sine Bar. So students, stay in the class, try to learn, whether you are learning right now live or you will be learning sometimes like in future. If you get any doubt, you can connect me there in Unacademy. You see, you can download the Unacademy app, and there in the GATE and ESE category you can search me, myself Rajeev Singh. I am a plus educator, so you search there Rajeev Singh, RAJEEVSINGH. Just follow me over there like you follow others there in Instagram and Facebook. And what benefit you will have that whenever I will be taking free classes there on Unacademy, I used to take some 15 hours of classes there on Unacademy platform, then you can easily come to know that Rajeev sir is taking class, and you can also be benefited from those special classes. So students, before I start this Sine Bar, I have some information for all of you. That is, this GATE Yodhas, this test series, a free test series is going on Unacademy platform. Those who are preparing for GATE 2022, the advanced test is there on 21st of November. That is the full length test for GATE. Yes, that you are looking at 21st November. 65 demons means 65 questions will be there, and that you have to answer in 180 minutes. So you can check your preparation well in advance without paying anything. What you have to do, just go to the Unacademy app, download the app, Learners app, and then go to the GATE and ESE category, and there you will find this GATE Yodhas and other special classes and free special classes. You will find me as well. So yes, they might ask you to use some referral code. So don't worry, simply whenever they ask you to use any code for anything, you can go for this referral code RK007 and then LIVE, since you are learning live, right? Great, awesome. So students, this is one of the information. Another information that I have, that if you come to our Unacademy app, we have a feature there that is called as raise a hand feature, where you can talk with your favorite educators in live class and you can clear your doubts. It's like offline class, right? But it's happening in online virtual classes. So click on the raise a hand icon from the vertical tab and click on raise hand, and then talk to the educators in a live class. I'll listen you, you listen me, and yes, other students who are there in the class will also listen us. So it will feel like very much like that you do there in offline classes. Yes. Moreover, my dear students, we have another feature there on Unacademy app. That's a great feature, that is Ask a Doubt feature by Unacademy. So whenever you get some doubt, you are doing the self-study, you can simply go to the app. There you can go to that GATE and ESE category, and there you can go to the doubt section. And whatever doubt you have, click its photo. If you are not understanding whatever the problem you have, you write it down, you click the photo and send it there in the app itself. Hold tight, you will get the solution, you will get the clarifications of and about your doubt. So guys, if you are planning to take subscription, then I'll recommend you to take the Iconic subscription, where you get one-to-one live mentorship platform, and let's make your doubt solving easier. You can book dedicated one-to-one sessions with your mentor. You can discuss your doubts, you can clarify your concepts, you can that's Iconic is the live mentoring sessions for GATE exam strategy you will be getting over there. So let's begin with this Sine Bar. My students, suppose you have a wedge shaped block. You looked at Sine Bar. This is how the Sine Bar looks like. There will be a bar here as you are looking at, and there will be holes into that bar. Why exactly are the holes there? Just to reduce the mass from here, just to reduce the weight. Great. And then you will have these two separate cylinders, like this one cylinder, and there will be this one, another cylinder, both these cylindrical rollers will have same diameter. If one roller is having, let us say, diameter D, then the another roller will also have the diameter D. So these two cylindrical rollers will be there, my dear students, and they are not like single piece. No, this roller is separate, this roller is separate, this sine bar is totally a separate piece. And this is one of the shape of the sine bar. It can come like in some different shape as well, like this. You can see the holding and gripping of roller will be relatively far better as compared to the above sine bar. Yes, chalo. So how do we do the measurement, the angular measurement with the help of this sine bar? Let's try to understand. Here, my students, let us say you have a wedge shaped block. मान लो आपके पास एक wedge shaped block है, वो कुछ ऐसा दिखता है. So this wedge shaped block is having like this angle, some angle theta. You don't know what exactly is this angle theta. You just want to measure the angle. So my dear students, here let us say this point is point A, there is this another point B, this point is there, let us say C, and that point is there, let us say D. What do we do to measure this angle? Apart from sine bar, we also need one more instrument that's basically a comparator, and that's called as dial gauge. Yes, you would have seen there in your metrology lab, or if you Google it, you can easily find that dial gauge. What exactly is dial gauge? There will be this dial gauge having its dial, and there will be this needle. If the needle is pointing 0, there will be a pointer here. Okay. If you move the dial gauge onto a plane surface, flat surface, there will be no movement in needle. But my dear, if suppose there is this slope over there onto a surface, and then if you move the dial gauge, this pointer will be forced inside, and behind this dial there will be arrangement of gears, springs, so that this needle will deflect from its position, and you will understand that this surface is like not a flat surface, or this surface is not parallel to this reference with respect to which the dial gauge is doing the measurement. It is sloped, it is inclined. If this surface upon which you are moving the pointer of the dial gauge, if it is parallel to the reference line, then there will be no movement into the dial indicator. Okay, you got the mechanism. Now my dear lovely students, try understanding how do we do the measurement. What I said, that you have this wedge shaped block of which there is some angle, and exactly you don't know how much angle is this, and that's what you want to measure. Let us say this angle is theta. You want to measure this angle theta of this wedge. Let us say that point is A, and this point is B, that point over there is C, and this point is D. Now you saw a sine bar like this. If you look at the center to center distance of the two rollers, from this center up to this center of the roller, this length between the centers of the roller, let us say if this length, my dear lovely students, this length is L, then this L is what we call as length of sine bar. Okay, if someone asks you, sir, what is the length of sine bar, you can easily answer him, length of the sine bar is the center distance between the two rollers that they are there having equal diameter and that you are using with the sine bar. Yes, my dear students. Now let me see whether my voice is clearly audible to all of you. I'll also come live in the YouTube live session. Yes, great, awesome. So I'm there. So what I said is that L is what? Your length of sine bar. Now try understanding how do we use this sine bar for the measurement of angles. You see, you will have a plane and flat bottom surface, and then what are we going to do is we are going to place this wedge shaped block onto the sine bar, and we will also have certain slip gauges. What are slip gauges? They are like highly polished rectangular steel blocks. All of them will have certain thickness like T1. There will be another bar, rectangular bar, it will have a thickness T2. So if you start piling them up now like this T3, you can get a height dimension. Okay, so we also use this slip gauge in combination with dial gauge into the measurement of angles with the sine bar. Okay, so guys, you will have this sine bar here. Let us say this is one of the roller. This sine bar is mounted there onto the roller, but my dear, what are we going to do is we are going to pile up certain number of slip gauges on the other end of this sine bar, so that the sine bar starts getting some tilt into the upward direction, starts getting certain amount of tilt into the upward direction. My dear lovely students, here you have this another roller, and this roller and that roller, they are going to have the same diameter, and below this roller what have you piled up? You have piled up the different highly polished rectangular steel blocks called slip gauges to build a height dimension. Let us say this dimension is h. That height dimension that you built up with the help of these slip gauges is h, while the radius of the two rollers, which are equal because they are equi-sized rollers, this is r, and there also it is r. Now when you are tilting it up, at that time this wedge shaped block will also be resting onto the top of this sine bar. So if it is resting over there right now, it will appear like this. Yes, this is the wedge shaped block. Now it will appear like this. Great. This is point A, that's point B, this is point C, and that's point D. That's your wedge-shaped block. And above that wedge-shaped block, my dear lovely students, there will be this dial gauge. Dial gauge will have its pointer resting there onto the top surface of this wedge-shaped block, and there will be this needle there. Now, my dear, what we'll be doing? We'll be piling certain number of, slip gauges blocks over here, rectangular blocks. The sine bar is getting the tilt into the upward direction, and meanwhile we'll also be doing one thing. We'll move this dial gauge, left hand side, right hand side over the surface CD, DC, from C to D, from D to C, from C to D, from D to C, to check that whether the needle is getting certain amount of deflection or not. My dear lovely students, if the needle is not getting deflected, then it only means, my dear lovely students, that this CD surface has now gone parallel to the bottom surface on which this roller and this slip gauge is resting, isn't it? Yes? If, my dear lovely students, the dial gauge does not, its needle does not deflect, what does it mean? It means that, the surface CD of the wedge block has become parallel to the bottom surface on which this roller of the sine bar and there the slip gauge is resting. And when exactly is this possible? If this angle is theta, then, my dear lovely students, think carefully, when will it be possible that DC, this line, will become parallel to the, bottom wrist? This is only possible when the sine bar is tilted by an angle equal to theta, isn't it? Then only it is possible. So, my dear, this means that if you look at this dimension from here, that is the length of the sine bar, to there, and let me draw another line with some another color. Let us say this color. One thing is there for sure, that this angle has become theta. Then only, my dear, that wedge-shaped block's top surface CD has become parallel to the bottom surface over here upon which the sine bar's roller and the slip gauge is resting. Great. Now look at this. This point is, let us say, O. That point is, let us say, here A, and this point is B. If you look at this carefully, this much is R, so this will also be R, so this will also be R, right? And from here up to this point, it is H plus R. From that H plus R, if you subtract this R, you are going to get AB. What is AB now? H plus R minus R, and that is equal to H. That is the slip gauge height. Awesome. And then, my dear students, this point O up to point B, this OB is what? Length of the sine bar, and you write it as like L. Now, in this triangle, you can write very beautifully in triangle OAB. Yes, this sine theta will be equal to H upon L. If you know this slip gauge height H, and yes, everyone knows when he does it, and if you know the center to center distance, that is the length of the sine bar, and that is how the sine bars are specified, then, my dear, you can easily find the angle of this wedge shaped block. But there is a catch over here. You know, we don't and we can't and we should not measure any angle above 45 degree with the help of sine bar. We should not. Otherwise, you will be getting, the measurement which will be full of errors. And why is it so? If you want to understand that, then let's look at this. First thing, remember this relation and also understand how do we do it. Because in GATE, when they will ask the question, they can bring the comprehension in the question, and if you don't know the procedure, how do we proceed, measuring the angle, then you may face problems in fetching the marks. So, dear students, if sine theta is equal to h upon L, let me write it over here once again. If sine theta is equal to h upon L, and what am I going to do is, I am going to find the error in the angular measurement. So, how are we going to find this? We are going to differentiate it. You see, if you differentiate it, you'll have cos theta d theta is equal to L square LDH minus HDL. Yes, or you can simply write it again, cos theta d theta is equal to dH upon L minus h upon L into dl upon L. I have just simplified that relation. There in the numerator, denominator it was L square, and on the left hand side you can see LDH. L and L was cancelled, so it was like dH upon L, and there I simplified, I wrote h upon L into dl upon L. So that's not a big thing, you can easily understand. Now my dear, you already know that sine theta is equal to h upon L, and here you look at this. What is that? H upon L. So we can replace this h upon L by sine theta. We can write cos theta d theta is equal to dH upon L minus sine theta into dl upon L. Moreover, you see, this L is there, but on the top there is this dH. I want to bring this L in form of h. That's what I want to do. So you know that sine theta is equal to h upon L. So L will be equal to h upon sine theta. Let's replace L by L is equal to h upon sine theta. So this becomes h, and upon sine theta, so sine theta goes there at the top. Yes, sine theta goes there at the top. Minus sine theta dl upon L. What can we do from here? We can easily take this sine theta out. We can take it like common, and then we can write, you see, cos theta d theta is there is equal to, you see, you took sine theta common. So sine theta multiplied by, you can write dH upon h minus dl upon L. Great. It's very simple. And if you want to write now here d theta, you can easily write it is equal to tan theta dH upon h minus dl upon L. You see, what exactly is this d theta over here? What exactly is this d theta over here? D theta is the error in angular measurement. This d theta, my dear, over here is the error in angular measurement. What is dH? dH is the error in the slip gauge height pileup. And what is dl? dl is the error into the length of the sine bar. So if you have some error into the length of the sine bar, that dl is there, or you have some error there in the slip gauge pileup, you can easily find how much will be the error into the angular measurement. Moreover, my dear students, please keep this in mind, that this d theta value that you will get from here will be in radian. And the errors are not going to be there in degrees, right? Errors means there will be like small errors, na? Decimals of degrees, or you can say errors will be very mostly like in seconds. Degree, minute, second, you know, na? 1 degree 60 minutes, 1 minute 60 seconds. So what you have to do here is, since this value is in radian, let me take another slide and I'll write it down over there. So when you find that error in the angular measurement d theta, that is tan theta, and multiplied by, what did you find here, is dh upon h minus dl upon L. So this value is in radian. What you do is, first you change it into degree. You know that pi radian is 180 degree. 1 radian will be 180 upon pi. So this much radian will be this much multiplied by 180 upon pi degree. But in degree this value will be very small. So what do is, we multiply it by 3600 so that you get this whole value in second. And mostly that error will be there in the second. But listen carefully. Here you see the error in the angular measurement of the sine bar is directly proportional to tan theta, na? Yes? Now, I hope all of you know how does the tan theta versus theta curve looks like. You know, it goes up gradually from here, but then it becomes exponential almost after 45 degree. Yes, at 45 degree tan theta value will be equal to 1. But as you increase the value of the angle theta, you go beyond 45 degree, na, what happens? The value of tan theta starts to rise exponentially. What will happen if by using a sine bar you will measure an angle which is more than 45 degree? Students, this will happen. What? Since the error in the angular measurement is directly proportional to tan theta, a theta value, if it goes beyond 45 degree, tan theta starts increasing, exponentially and starts tending to infinite. This error will become very, very high. Yes, error in angular measurement will become very, very high, and that's why the reason, my dear students, we don't use sine bar for measuring an angle which is more than 45 degree. Yes, you got it beautifully, since it was nicely explained to you. So my dear lovely students, for the upcoming GATE exams and ESE exams, this thing is very, very much important. Yes, very few people understand this concept, that why do we measure only angles up to 45 degree with the help of sine bar. That's a very good thing to understand through mathematics, that why exactly do we measure an angle less than 45 degree with the help of sine bar. And you have the answer, because the error that you calculated here beautifully with the help of mathematics, you found that error d theta is directly proportional to tan theta. Error in angular measurement is directly proportional to tan theta. And if the theta value goes beyond 45 degree, d theta, tan theta rises exponentially. That is, d theta will also rise exponentially. That is, the error in the angular measurement will start to rise exponentially. You don't want that, right? So we'll have some other method. We have precision ball measurement method to measure the angle. So instead of using this sine bar, we will be taking help of some another method, or we can even take the help of angle blocks. Like slip gauges are there to pile up the heights. We'll have angle blocks to build up the angles, and with the help of that also we can compare and we can measure the different angles, or we can use precision ball, and with the help of those balls we can do the measurements. There that error will not be there. So sine bar is good to measure the angles, but for angles only below 45 degree. So my dear students, keep coming and keep watching these YouTube lessons. Moreover, स्पेशल प्राइस वीक चल रहा है अभी. अगर आपको सब्सक्रिप्शन लेना है तो 10% तो जो रेफरल कोड आप लगाओगे RK007 लाइव, उस पर जो डिस्काउंट मिलता है वो तो मिल ही रहा है, साथ के साथ 10% एक्स्ट्रा डिस्काउंट मिल रहा है. तो स्पेशल प्राइस वीक है, फटाफट ये खत्म होने वाला है. इससे पहले कि खत्म हो जाए सब्सक्रिप्शन ले लो. एंड मोर ओवर वी हैव स्टार्टेड दिस बैच एंड वी आर स्टार्टिंग दिस बैच पी फॉर आरोहन. तो जो लोग 23 के लिए स्टार्ट कर रहे हैं प्रिपरेशन, आ जाइए हमारे साथ प्रिपेयर कीजिए. जो लोग गेट की तैयारी कर रहे हैं वो लोग 3-4 महीने का और ESE का भी उसमें प्रिपेयर हो जाएगा, उसके लिए ले सकते हैं. और 3+1 ये भी चल रहा है, 3 महीने का सब्सक्रिप्शन लोगे 1 महीने का फ्री मिल जाएगा. सो डोंट मिस दिस चांस. एंड अपार्ट फ्रॉम दैट, join me in special classes as well. So what you have to do, go to the Unacademy platform, go to the GATE and ESE category, find me by my name Rajeev Singh, follow me, and you will be getting the notifications of all the free classes that I bring there on the Unacademy app. Yes, so that's a great thing to do. Come on guys, we are done with Sine Bar, so we will be meeting tomorrow again at the same time, that is 9 PM. Yes, so please note down this time, put a reminder in your phone. I come every day, Monday to Friday, and Sunday today I came especially. Generally I don't used to come, but Monday to Friday I used to come every night like 9 PM. So join me every day 9 PM and you will be getting some really beautiful concepts, amazing and peerless undoubtedly and unmatchable. So if you want to learn the same way, unmatchable way with me, you can also subscribe and find me there and come and ask me. I'll guide you how to prepare for the upcoming GATE 2023 exam. So guys, see you all. Bye bye. Tomorrow again we'll be meeting with some new concept. Follow me there on the Unacademy app. Bye bye.